Hello, and welcome to the first episode of Meeting C++ Live. Today I start a new format in the video format for Meeting C++. With my first guest, Rainer Grimm, which is a speaker and book author, blogger, and welcome to the show, Rainer.
Hello, my name, of course, is Rainer Grimm. Should I say a few words about me? Jens,
Sure.
I think I
Yeah,
should do
please
it.
introduce yourself.
I'm a software developer since 1999, software developer, software architect. I was a few years responsible for giving seminars, for managing seminars. At 2014, I switched to a different company. I was responsible for software on defibrillators. I did that until April last year. And since April last year, I'm totally happy because I'm an independent teacher, um, consultant, coach around Python and, of course, C++. I think that's enough about me.
Yeah, yeah, that's kind of also how I got to know you, Rainer.
Good.
The thing I noticed the most in last 2 years is how much you're blogging, and that's why I decided to have you as a first guest. Because originally I planned to focus on C++ content with the first episode, and maybe have another blogger like Arne Mertz or Jason Turner who does a lot of video and CPP cast. But I thought then maybe just have this as like a first short topic and then go into another topic. And as you have a very active blog, and as a coincidence, you actually have now all your German blogs synced with the English blog.
Mm.
And so my first question to you would be like, will we see as much content in the future from you as you had in the past?
The answer depends. What I mean by depends is I will blog once a week. I will do it in English and I will do it in German. So I will calm down a little bit. So I will publish at Monday. That's my plan. And of course, I will do it in German and English. And yeah, what should I say? The first post I will write will round up the old post. That means I will add a few posts about functional programming, about multi-threading, about embedded programming with Modern C++. And in case I'm done, I will make a survey and to get an idea what stuff you are actually interested in. I
Mm-hmm.
can think about stuff like let me think about from C to C++ or generic programming or also clean code. So
Yeah,
we will see what will happen.
yeah, I usually use blogging as kind of a clean code routine to write about things I'm currently writing. My own focus currently is on my own CMS, which I'm now working for almost 2 years on,
I know.
and to get the first website ready with it and get some other features ready so I can start with the main website for Meeting C++, which I hope to have everything live with a new website like in the end of April. In between, I have to announce a conference and have to kind of do every content for the conference twice at the start a little bit, but also I already am a little bit set up that the systems which allow you to submit talks, etc., are separate from the CMS which I'm currently using, and are separate from the CMS which I have developed. Um, so let's just have a quick look at your blog, and then I thought we start to talk about multithreading. But one thing about C++ content, I wanted definitely to say it's one of my main jobs is to post and read a lot of blogs and to see a lot
Mhm.
of videos. And there's over 300 sources for C++ content, which I have in my reader
Mhm.
or RSS in my reader, and that's pretty awesome to see. And it has become a lot more. And the top one and the top two in the last 2 years, as if I remember correctly, was your blog. If we take out like a few very active blogs, which are companies, or but the
Mhm.
one single person having a personal blog writing about C++, I was kind of astonished about how many blog posts you wrote. But I guess you know having a past as a book author and being able to easily write is probably a good advantage there.
But to be honest, it's not so easily in case you write about the new stuff. You have to read the proposals. You have to get an idea what are concepts about, what are task blocks are
Yeah,
about. So you have to make a lot of information. You have to read the information and you have to provide them in the right way, and that is not so easy to do.
yeah,
That is the reason I'm totally happy that I will now calm down to uh, um, one a weekly issue of my blog.
yeah, yeah. That's something which I also heard from Scott Myers. Scott said like it's difficult to be Scott Myers for the new standards, as everybody still has to get their experience with C++ and the new standards before I can be Scott Myers for them, and then I probably don't have the time to be that anymore. So it's uh, but we actually wanted to talk about multithreading.
Hmm.
So I'm gonna switch to the first blog post from you from February, where you wrote about multithreading with C++ 17 and 20.
Yeah.
So this is currently, maybe your compiler ships already with that and experimental, maybe not. But the big news, but maybe let's just start with the arc, what we currently see, the C++ 11 to 20 arc.
Hmm.
What's the different features we got with every standard there, Rainer?
Okay, you're referring to this picture. Okay. For me, there's a big difference between 14 and 17. That means all before 14, 11 and 14 is about the, how should I say it? That's the implementation. That is the assembly language of concurrency. What does it mean? These are the basic building blocks for building higher abstractions. So C++ 11 and 14, including, of course, multi-threading stuff like threads, tasks, thread local data, condition variables, and of course, the memory model. These are the building blocks. This is the stuff which, from my perspective, is the stuff for the library developer, so for the people who makes the infrastructure. And
Yeah,
with 17 and 20, there's a big mindset shift, meaning now we have the stuff for the application programmer. That's a Because now we have not to deal with threads, we have not to deal with logs, mutexes, we have no condition variable, which is extremely hard to use the right way. I know it by heart. Now we are working with threads or with our multi-cores on a totally different level.
yeah,
And that is for me the big shift.
yeah. I personally see it there. So my multi-threading needs are either already in Qt. So when I have to do multi-threading in my UI applications, I use that, or I use often also Boost, because Boost thread already contains a lot of things like futures with stop
I know,
then,
yeah. Hmm.
which are, as far as I know, are not going to be in the standard until C++ 20, but we're going to have a look at that later. So let's scroll down to the first example of C++ 17, which is very neat that we are now able to have the parallelism which we want for C++ in the algorithm library, which makes the parallel basically now being able to execute parallel algorithms.
Yeah, that's only an introductional example, only describing the different ways to use to sort with the old syntax and with the new syntax.
Yeah,
What does?
we're going to be in details with that later.
Okay,
I have
okay,
4 other blog posts of you open which go into details,
okay. I
and
see. Hmm.
um, then C++ 20. I don't really want to, it's hard to predict the future. So this is all things which we might see in C++ 20 and which we partly covered today. Um, Parts of that is in Boost already available. So maybe you want to look at Boost thread and see if that's good for you, or if you want to use it in your multi-threading code. Coroutines are available in Boost, but currently it looks like if we really get coroutines in C++ 20 or a standard below, or after that, then that will be a language feature, which is, in my opinion, much better and much cooler than the library features which we currently have with Boost. But let's continue and take a quick look.
Okay, I will make it quick because we can dive deeper into the details. So
Yeah,
what we will
on task
get with
blocks.
high probability is atomic smart pointers, which makes a lot of
Okay.
sense because we should not touch memory on one side, and then on the other side, we have many threads or
Yeah.
many cores, so we have to have something which is atomic. In this case, atomic smart pointer. Then what we will also get, which we had from C++11, is std future extensions. That means std futures which can, in contrary to the C++11 version, that can be composed. That's the key idea of the
Yeah.
future extension.
Actually, I this is something where I just this how can you use futures without that? You know, that is what makes futures usable to the user in most situations. So um, at the end, we will need to have some libraries implementing this, or we will have to wait another 3 years to have it in the standard. So that's where Boost shines. Boost Future has that for years,
Mhm.
and
I think Qt also, as far as I know.
yeah, Qt has an own concurrency library, but
Mhm.
I usually only use the thread pool and Qt to execute some tasks in the background. And the heavier multi-threading I do with Boost thread, because I know
Mhm.
that's how it's going to be in the standard one day, and then I can do it with Boost today, and as soon as it's the standard, I can just switch to the standard and be mostly all right. So let's continue with your next blog post about task blocks. Um,
Should I give an overview or should I go more into
um,
details? What's
they,
your
I read through that last night, and I had some questions or some question marks on this.
Mhm.
Um, Especially like what is the idea behind task blocks?
The idea from my perspective is relatively simple. You have a kind of a fork join paradigm which you want which you want to use or which you want to implement. That is, you have a task block in which you have the possibility to start a task, and so you have um, a fork phase and a join phase, and there is a synchronization point, and at the end of the synchronization point, your job is done, your tasks are
Okay,
done.
so basically, the the system behind this takes care of the synchronization, and you can spawn jobs and then
That's a
have a
good
certain
point. There's no
synchronization point.
synchronization or
And
locking mechanism you have to implement by yourself, or you have to use.
when I look
That
at the
that is
examples,
okay.
when I look at the examples, um, so this is where we again see that, you know, the future of C++ has a lot to do with lambdas and callables, etc. So this is
Mhm.
really a nice thing, but I am not sure. And at the end, you write here about schedulers, and this is like a good point. This is like we still need to have the whole framework for executing code in parallel in the standard. And upon that build so much. Also, Agio needs that, and I hope that we really. Um, I saw a paper on executioners, I think, for the last meeting, which will be there an important unification and update to the standard. So some part of that probably will make it to the standard in 20, and in the next 2 years, we'll probably get a feeling for what this really makes it. And
To be honest, my point is, Mrs. Blocks, is not about what will come in the future. My point is what kind of abstraction we get. You know what I mean?
oh
I'm
yes,
not.
I understand you. I understand you.
I'm more interested in the mindset shift. which will enable us to to deal with multiple cores. From my perspective, with 11 and 14, it's not so easy to be extremely careful. You have blocks, you have locks, you have deadlocks, you have live locks, you have
Oh yes.
terrible. It's terrible, to be
Yeah.
honest.
Yeah.
I have to teach that, and I say you write 3 lines of code and you have no idea what's actually happening. Maybe it works today, maybe it works tomorrow, but maybe a compile upgrade or a faster CPU and the deadlock appear. That is terrible. And so I'm interested in the right kind of tools we will get with 70 and 20, and these are for me these are the tools we can handle.
Yeah.
We mortal programmer.
Okay. Let's have a quick view on one feature, like the ledges and the barriers.
Okay.
Um, so this is basically if you want a central point to wait for multiple threads and to synchronize.
Hmm.
So this is similar to what we saw before, but it's a different approach, right?
What do you mean by similar? For me, it's a kind of semaphore which we actually do not have in C++.
Yes. So you you
It's
you
you
spawn again. You fork several threads.
okay? Yes.
Like in the previous, this like the spawning in the pool is the forking, and then if you ask the ledge or the barrier later to wait, that's where everything gets synchronized, or is
Okay, yeah. You wait until the counter becomes 0, and the difference is between ledge barrier and flex barrier. If you can iterate only once, more time than once, or you can adjust the counter. That's the difference. But the
okay.
key principle is the same. A counter which will go to down to 0, and then something different happens.
Okay. Yeah. And one thing you told me, these examples are actually from a standard proposal.
Yep, you're right.
So using new thread is not like the way you should do it. You should maybe make sure that this resource gets wrapped
And
um, into
that
something
was
which cleans up.
that was the reason I added a note to the post.
Yeah.
Because, of course, you're right. I get a comment from a other reader which mentioned a similar point. That's, of course, right. But my idea was to use the examples from the proposal and
Yeah, which
maybe.
is a good idea. And I'm just just trying to tell people that this isn't your idea, okay? Um,
I fixed
and
it.
as far as I know, barrier ledge, etc., that's already for years covered in Boost thread. So and then I think far more interesting because it's far easier to use and a lot better concept for me is actually like using futures. And this is your blog post about the future extensions,
Okay, yeah.
which is another candidate which is extremely likely to be in C++20. Um, that's actually something which I would have liked to see already with 14, but this looks like such an easy feature that you very easily forget how complicated the implementation can be, or that you really have to get the implementation right. And this is one of the issues which we currently. This depends on executors, on executioners, etc., and schedulers, etc. And this
Hmm.
is why it's currently not in the standard, as far as I understand. Um,
Of course, we have them since C++11. We recognize there are a few drawbacks. In particular, you cannot compose them. Now you can do it. With now, I mean the C++20 version. From my gut feeling, I assume that we will get them with relatively high probability. Because for me, it looks like it feels like extremely I don't know how to say it. I would say ripe. So it looks good. It looks complete.
yeah, I agree with that. I think the API for this is stable.
Mhm.
And it's basically about what do we get in the standard. And so I see here there are 5 extensions which are in discussion. It's like a constructor feature, Heading
Okay.
is ready, so that you can test if the feature if the future is ready. The .then method to have
Continue it.
continue it, which is extremely important if you work with futures. And
Then, of course, when any and when all.
yeah,
So you get a bunch of futures and
let me quickly
then,
scroll down.
sorry?
Um,
Okay.
okay,
When
yeah.
you get a bunch of futures and the resulting future is ready when any of the underlying futures is ready, and
Mhm.
when all, you know what this means. And what I extremely like about this futures or extended futures is that actually under the hood that is a monad. That means that is a higher order functional concept. And do you know this well-known talk from Bartosz Milewski? I see a monad in your future. So here you have
Mm,
it.
not sure. I've seen a lot of talks on futures and mods
Now
and
have
past.
I refer to them from Bartosz
Yeah,
Milewski. That's extremely good, and he
yeah,
says what should be done or what should be added to future to make them a monad, and then you can compose them because now they are mathematical structures which follow specific rules, and now you are done. And that actually happened with the C++ 20
yeah.
futures.
I use when any in my code.
Hmm.
Um, when in my CMS, when I generate the pages, I do this in a way that every page has its future which generates it, and
Hmm.
then at some point it returns. And this generates a string, and at some point I have to write that to a file. And so I use when any to get the next future which is ready and unwrap that, then write it to a file. And so with that you can kind of easily implement producer consumer features which are in the other
Hmm.
ways not that easy covered. And
To be honest, I'm a totally fan of futures, even the C++11
oh yes,
flavor, because you have a higher abstraction above threads and above condition variables, which both
so
of them are extremely difficult to use in the right way.
one
And
thing we didn't cover from your blog post here are the differences between std async, package task, and promise.
sorry, I don't get you. What do you mean by
Um, so the I'm talking about the creating futures section of your blog post. So we have methods like make ready feature, which make ready
Oh, okay,
future,
I see your point. Okay.
and std async, package task, promise, which already exist today. So is there anything new in the future standards, or is this just an add-on?
That is this function you mentioned, like package task. They return an extended future, or to say differently, a C++20 future, which has under the hood these methods I mentioned before, like unwrapping constructor, a predicate is ready, or the method then for continuation.
Oh,
That will hold for all of these three promise. Stud async is under the hood a promise, stud package task is a promise, and stud promise is a promise, of course.
okay. That's good to know. I see we have one question from the chat, and this is: will futures be composable with the previously talked about parallel processing constructor, the parallel SDL?
Will future To be honest, I cannot answer the question.
I'm also not sure about this. That's
For me, that's are two totally different topics. I don't know.
yes,
Maybe
but
I don't
maybe
know.
let's go next to your blog post about the parallel algorithms, because that's
That
like one of the last blog posts I have open from you.
okay?
And this is definitely I think this is the feature for C++17 for parallelism, which we
Yeah, okay,
get
of course,
is
yeah.
to execute things in different ways. And maybe Rainer, could you quickly talk about the difference between parallel sequential, par, and par unsequential.
So with C++70, we can execute an algorithm, the most of the algorithms from the STL, with a so-called execution policy. We have three of them: sequential, of course, sequential, then parallel, of course, that means parallel, and par unsec, that means parallel, and um, with SIMD instructions. So you can perform SIMD stands for single instruction multiple data. You can perform one instruction in parallel on multiple data. That is the a little bit the explanation for the acronym or for the abbreviation. So par unsec is this parallel and with SIMD instruction. That means under the hood SSE or this kind of special assembly instruction which can run on special registers so that you can run one operation on many data in parallel.
Yeah. So the C++17, we have the first ever port for SIMD
Hmm.
for single instruction multiple data. Even if it's just for algorithm and not like really as a library. But I heard that they're probably within this year, Boost will have a SIMD library from Joel Falcou.
Okay, Joe. Okay.
And let's look a little bit about deeper in this post. So you're showing here a little bit of the generated assembler to show the difference.
Okay, the point was that I only want to show the difference. What is SIMD? What does it look like?
Okay.
I only showed a small code snippet which
Yeah.
added to C-Arrays, and I translated, I compiled this without optimization and with optimization. And what you can see, was for me extremely good to see was, in case I do it without optimization, I have the normal assembly instruction I'm used to. Assembly instruction which works only on one data.
Yeah.
If I do it with maximum optimization with Clang 3.6, and of course I use the Compiler Explorer Goldbolt, that
Yeah.
helps me to have a look at the assembly instructions.
Yeah, that's actually the tool to play around with that to see what actually
That's
is the difference.
I cannot say it. I have to say it once more. That's a great tool. It
Oh yeah,
helps me a
I
lot.
love it.
I use it often in my seminars to show what actually Const Expert will do under the hood.
But let me get back to the question from the chat which we just saw, and I think the hazard and of data races and deadlocks
Hmm.
in your blog is kind of covering this. So I think like it is safe to call these parallel algorithms from a future, which is like already running in parallel on your machine.
Hmm.
Um, but of course you have to see the lambda which goes into the algorithm.
Okay.
That is what is executed in parallel,
Yep.
and that's where you have to be aware of that you shouldn't have like global state which changes or that there
Yep.
deadlocks could occur or
That is a kind of an artificial example, but of course it shows the problem. Numcomp is in this case a global variable, and of course it will be written or modified by more than one thread.
yeah.
That is per definition a data race, and therefore the program is not is has undefined behavior or catch fire semantic. I like that more.
Okay, so would it help to make numcomp atomic then?
That is a good idea to do it, but that was so a strange example. But of course, from the
Of course it's an example.
now it would be well defined. In case numcomp is atomic, it's fine.
Okay, so I think that's like definitely like something to watch out for when we refactor to C++17. If the lambdas which we're using in our algorithms contain such traps where variables are in this scope like global. This also counts for things like shared pointer. to really see if there's some state which is shared between the
Mm.
different instances of the algorithm running on the machine. And
To be honest, you can shoot yourself in the foot with 17 or 20, but it is a little bit harder, a lot harder.
yeah, of course, or it's like that's a major feature of C++ since the beginning.
Yeah, but now
Um,
it's harder. That is fine from my perspective.
so uh, I see that there is the next chapter is about static versus dynamic execution policy.
Yeah, the point was you have to decide if your algorithm should run in parallel, should run sequential. You can do it at two time points. You can say it at compile time, or you can say it at runtime. And that's the point about static versus dynamic execution policy. At compile time, it's for me similar to specifying it at the source code level. What does it mean? I have, in case you look at my example, there's the quicksort
Yeah.
implemented with std partition. And if I do it extremely naively, what will happen? Quicksort is a so-called divide and conquer algorithm. That
Mm,
means the idea is each time I invoke std partition, I assume I will create a new thread. That is extremely bad. Now the number of threads is a lot too high for my system. Maybe I don't know it, but that's the problem. That is one problem. The other problem is in case you have an extremely small vector or container or something like that, it makes no sense to let the program run in parallel because the managing overhead will outweigh the computation overhead.
oh
So
yeah.
do, and that is the reason why you can say maybe if I'm below a specific threshold, I should do it in sequential. Should do it sequential. If not, I will do it parallel.
But
That
are
makes, from my
are
perspective, a lot of sense.
are we creating like a thread per? I mean,
To
is
be
is is
on,
is,
to
is,
be,
a, is a scheduling system which is based on this, which actually does a parallel execution in the background. Um,
actually,
is
I
that
don't
thread
know,
based?
and I don't know, and
Okay.
I don't care. I care only on the task I want to perform, on the job which should be
Well,
calculated
that
as
is that is
fast.
a that is the question. Is this a system which has like the ideal number of threads for your system and then runs tasks on them, or is it a system which creates a thread for your task? And I think it's the first one, as far as I remember.
I'm not sure, to be honest. There are a few implementation of the new standard template library available, HPX, one from NVIDIA, and other ones. Um, I have no sentence in my
Okay.
head saying specifically what is the exact behavior. I'm only argumenting here conservative.
I think it's a task-based system. Maybe it stands at cppreference.com already. Not sure. That's something to look up if you're using this.
Mm.
And probably yeah. Also, you want to measure the impact on your machine, I
But
guess.
I have to add one sentence. I posted
Yes.
this example in German, and Hartmut Kaiser, now I can speak German. Hartmut Kaiser made a comment, and he didn't say anything about this, about my sentences here, about my statements. HPX, Hartmut Kaiser is the one of the implementer of HPX. That was my point.
Oh, of course, yeah. This
Mm.
was just something that came into my mind. It's not about what you write here for.
So if I made
So
an error here, I think he would make a remark because he remarked a different point about my transform algorithm, which I will show in a few seconds.
yeah. Um, so I see the next section is about all algorithms.
Yeah, you can count them 69.
Okay.
Okay, 69.
So yeah.
Sorry,
So
all of them
these are all
can.
covered.
Sorry?
by. So these are all the algorithms now which are visible.
Yeah,
And
okay. That's a screenshot from the proposal or maybe from cppreference.com. I don't know it exactly.
that should be cppreference.com. That looks
Okay,
very
you
much
are
like
right.
it.
Okay, these are the algorithms which should work in parallel, sequential, and parallel unsec. Or
Mm.
and we get all in addition we get 8 new algorithms, which you will see a few lines below.
Okay, let's go to
Uh,
that.
okay, and what I like is there is one new algorithm called transform reduce. And if you know a little bit about functional programming, you know that transform in functional programming is called map. The same holds for Python. It's called map.
Mm.
So what is map in the functional world is transform in C++.
Yes.
So you can translate transform reduce to map reduce, and then you know what the algorithm will do. It's a kind of a map reduce algorithm. That means MapReduce consists of, or transform reduce consists of two phases. In the first phase, you map or transform each input value to another value. In the second phase, you reduce this intermediate results or values to your final result. And that is the MapReduce framework, and here it's called transform reduce. And so you can, like I did it here, I have a string of, sorry, a vector of strings. In
Yeah.
the transform
Let me
phase,
scroll down to the example. Okay,
sorry,
so yeah.
in the transform phase, I map each string to its length. And in the reduce phase, I add these lengths together, and the result is, of course, the length of all strings.
Yeah.
So kind of map reduce in the C++ area.
Yeah,
I
that's
was
very
extremely
nice to have that in one function.
And of course, it's parallel. And maybe if you have an implementation which will run on many, many cores, many, many PCs, many, many devices, it may become extremely, how should I say it, efficient. It's a question of the implementation of the standard template library. If you have one,
Yeah, that's I think that's basically the next point to say is all this is going to be available in a lot of compilers probably soon as an experimental feature, and then later it's going to be available in the next C++ 20 standard, which is just 3 years from now. And
okay, yeah. And
as far as I know, that's the one of the features which is not covered by Boost.
okay. Once more, what I want explicitly want to mention, what is great about 17 and 20 from the user perspective. Now we think not about implementation like threads and that stuff on condition variable thread local. We only think about the task we have to perform. Only what should be done, not how it should be done. That's a we are now discussing on a different level, on a totally
Yes,
different level, and
yes.
that is extremely great.
I think like parallelism based on futures is much more accessible and less bug prone. Like Sean Perrin, also says like you shouldn't use like low level parallelization things like mutexes or ledges, etc. You should use the future libraries which are today already available. With like there's the PPL from Microsoft. Intel has the
TPP,
yeah,
Silk
and Boost
plus
has
plus
also
is
code on
mhm.
this. So that's usable today. And of course, if you want the standard version, then you can use either Boost, but HPX is definitely something I should mention in that context.
That's okay. Yeah, mhm.
Hartmut has done some awesome work there, and um, HPX is also a system which is able to execute your code on multiple cores, but also on multiple machines. So if you want to run several nodes to speed up your processes, that's like HPX, I think, today.
Uh, Codeplay has also an implementation of the parallel SDL. Codeplay is the how the semi press nee, Michael Wong is actually working for Codeplay. That was only my point. So there's another implementation available which you can use. I think it's called Cycle or something like that.
Yeah. Yeah, Circle is a different feature. But we had a talk about Circle last year at Meeting C++. So if you're interested in Circle, you probably want to look up this talk. And I probably in not too far future, I plan to have Michael Wong on the show, and we might talk about this. I know that parallelism is like totally his topic, but I know that he's now interested with SG14, etc., and other things.
Mm.
So there's a lot of options to go parallel in C++ today, and there is Codeplay. There's a lot of other companies, and there's a lot of books which you might want to read. So this brings us to the end of this show. I see there's another question in the chat.
Okay.
And yeah, I think I can answer this. So this is about what happens when two parallel functions both call a parallel algorithm, and I think that the standard takes care that the code and the algorithms itself is thread safe. So I think that's okay. It shouldn't. I mean, if that is a problem, then why have it in the standard in the first place? That would be a problem that wouldn't pass the committee. And
Okay, yeah.
so it's just I think that's one thing we have to see with this feature is like if we parallel everything in our systems and every algorithm call in our programs, how much how much our machines are gonna be under load from that, and how much more load is generated through putting that through systems which put it in different tasks and execute it on the machine. Though there
You're
is an
you're
overhead
you're
probably.
totally right, but the point is now it's not our job to make that smart. That's the job of the people which implement the framework, which implement the standard template library.
Of course,
And that is the great, they can do it, we cannot do it. So that's for me the right way of abstraction which we get.
yeah. So you already were about a bit talking about C++20. Maybe we should. I saw you had also some posts on concepts, and I think that concepts and modules are very likely for C++20. So should we have a quick view at that?
I cannot say much about modules, but I only can say a few words about concepts.
Okay.
I was totally astonished, in particular as I looked a little bit about how that will interact in a very nice way. I mean about auto and concepts and function template, and that becomes totally homogeneous, and that is extremely great. I think that was the feature I saw in the last year in C++, which impressed me the most. That is, for me, a kind of a quantum leap. I don't know how to say it in a different way. That now we can define a function using a concept or using auto as a placeholder, and what we will get is a function template without without brackets, and that is great from the user perspective. Extremely great. We have generic programming, we have concepts without the ugly syntax.
Yeah.
I'm totally, how should I say it? Totally impressed, and I will write my next post about placeholders.
There
Uh,
there
that will happen at
was
Monday or something
yeah
like that.
yeah. That's actually something interesting upcoming. There was already a post from Jaffa Trull on his blog. I think it's covered in the last blog roll or in the blog roll tomorrow
Hmm.
about concepts. No, it should be in the blog roll tomorrow because it was this week. and he basically shows like how to use concepts, etc. And what I found also very interesting is that concepts play a very, very important role if you want to you want to look at the features of the standard for reflection. So all
Okay.
reflection proposals which are already like having like a serious thought through, um, they usually now define their interfaces and their implementations by concepts,
Hmm.
and that's like it. That's like this is the interface for for reflection, how the standard should provide it, but they don't like provide an implementation. Though there's not like a standard reflection class, but there is like a like the standard defines an interface and it leaves the implementation in this part to the implementers.
Hmm. Okay. I only skipped through my blog post, my last one. Yeah, the next one will be more interesting. I only talked in the last one about constrained and unconstrained placeholders. And
Yeah,
as I mentioned it in the post, I often have the question in my seminars, when is a programming language simple or easy to use? And functionality like the concepts, in this case, constrained and unconstrained placeholders, makes C++ extremely easy to use because there's one principle you have to keep in your mind and all other stuff will derive from it. And that is great from a teacher perspective.
yeah,
I'm totally impressed, totally. So I'm not objective. Sorry.
yeah. It's I'm looking forward to 20 definitely.
And then I only talked about the usage of concept. We did not talk about the mathematical background, like defining concept, like defining concepts which express a kind of type. That will also come, of course, and that is a great benefit we will get from the type system perspective. I think we are not aware of it. At least I'm not aware of it. What actually will happen with concepts? How or
oh
how
yeah,
the language will change?
but
I'm relatively sure.
I see like first people are picking it up and playing around with it, and there is an implementation available in
GCC.
in GCC,
Hmm.
and for 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 C++ 20, it's probably very important that we see like an implementation in Clang or in the Microsoft compiler soon, that we can have some feedback on, if like we have the one implementation, but if we have a second implementation, maybe we see like things which
Okay.
we want to
Hmm.
change in details or something. But as far as I understood people which are in the committee in the last year, in the last month, there's kind of an interest to get concepts in the standard and to follow up with this. But also there's still some open questions for some people. So this is still a very interesting field. But if you want to play around with that, that is available in GCC currently.
Yeah, yeah, that works. I don't know which one. I used the 6.3, which is, I think, from December last year. So that one works. You have only to specify in flag like -f concepts, and then it compiles, and then you can see it in action.
Yeah, and that the same thing is true. Like modules are available in the Microsoft compiler,
Hmm.
and Clang technically already has support for modules, but in a different way. And I think that Clang probably will be there, or maybe already has adopted to the standard way.
Okay. Uh-huh.
So yeah. Um, and as far as the committee meeting was just last week, and C++17 is now fully ready to become a standard.
Hmm.
And this I'm not sure. I remember with 14 it was like in August when it became an official ISO standard. Um, and that probably will happen again with 17. Maybe quicker. Maybe. But what the big difference we saw with 11 to now is the speed features get implemented. So we already now have compilers which have most or all features of C++17 implemented. So if you want to play around with these features, that's already doable today, which was when with C++11 like nearly impossible. And this is a great change, I think. And so the things which are not in the standard are in TS, but this is then available under experimental.
Okay, I know. Should I say a few words about the structure of my blog?
Yeah, sure.
That's the stuff I want
That's
to say.
I think we are through with C++20 and multithreading, so we just
Yeah, the details, you can read the details in my posts, of course, and now I want only to say a few words. Because my problem now is my blog is a little bit. I have a lot of articles, a lot of posts, around 130 or 40, depends on the language.
mm,
And I should give you a guide how to find the right post. So, at first, in the right corner of my blog, there's a
one
start here.
moment. Yeah.
There's a start here button. If you click on it, you will get a kind of a talk which gives you an overview of all posts I have written.
Mm,
And of
yeah.
course, you see the.
So if you go to modernuscpp.com,
Mhm.
you see that. In fact, I'm just gonna click on this start here. Let's see where I go. Okay. So now I'm at a page titled Modernus C++. A bit of Denglish. And
That is not per accident. That only respects the history of my blog because I started with a German blog. The name of the
no, I
German
think
blog
it's
was
perfectly
Modernist C++.
fitting. It's perfectly
That's the
fitting. It
reason.
fits you to 100%. That's perfect.
Yeah. And I
And
have reserved the domain, so I'm
so
totally fine with it.
that's where you get a total overview on everything which is on your blog, and it's like this is awesome.
So to get an idea, then I have uh, once more back to the right of my right side of my blog. I have categories. Each post belongs to one category, and you can guess from the
Okay.
title what's in there.
So your current categories are embedded, functional, multithreading, applications, yeah, multithreading
Memory
is
model.
multiple, and then news and overview.
Okay, yeah, and maybe there will come new ones, but we will see.
Okay.
Then I have tags. That means each post has one or more tags. Like I have the tag, I will start here, acquire release semantic for dealing with the memory model, async for dealing with std async, atomics, and I think it's, you have an idea from the word what's actually inside.
Mm-hmm.
So that's the third kind of guide I will give you to get an idea
Yeah.
to come to the right,
Yeah,
to
but
find the right post.
most of these are like common categories or common things to have on a
A,
blog today.
a category is, yeah, yeah, okay.
So
Then a block
um
archive. Yeah, that was it under the hood.
yeah,
I have a search functionality, but to be honest, I I never use it because I know where my stuff is. Maybe you have to use it.
okay. So thank you, Rana, for being my first guest, for being the volunteer, for being the guinea pig. Thank you for this.
Oh, thanks. You're welcome. Yeah.
And I'm not sure when the next episode is and with whom. I have to see. But everything is set up now, so I can I can go live when I want, and this is probably going to happen. So there's not like a certain point in the future when I want to have the next episode. Um, and I'm looking forward to more blog posts from you. And like once a week is also how I try to blog, but not always have time for this. Like today and yesterday, I had to do a lot of preparation and testing for this.
Mm,
And um, with that, I'm gonna stop the stream now. Thank you everybody for watching.
okay. Thanks also from my side.
And but I see there's still some people in the chat. So if you have any questions to Rainer, Um, Rainer probably is able to answer them, or I'm probably gonna, or everybody in the chat, let's just open the discussion. And